Here we have a three-dimensional coordinate system which has the x-axis, the y-axis and the z-axis. We already knew that the x-axis and y-axis are perpendicular to each other. We will now say that the z-axis is perpendicular to both the x-axis and the y-axis. If we have to take a two-dimensional vector in this plane, it can be easily represented in the x and y direction. For example, let us take a two-dimensional vector 5i cap plus 2j cap. We will say that to get to this vector, I will move 5 units in the x direction and 2 units in the y direction. The vector that I can now see is 5i cap plus 2j cap. Now if I wanted to find the magnitude of this vector, I will say that the magnitude is equal to its length, and this length can be easily found using the Pythagoras theorem. This magnitude will now be equal to under root of 5 square plus 2 square. Now let us say I have a three-dimensional vector and this vector is 5i cap plus 2j cap plus 3k cap. To get to this vector, I will need to move 5 units in the x direction, 2 units in the y direction and 3 units in the z direction. The vector that I can now see is actually 5i cap plus 2j cap plus 3k cap. Now if I want to find out the length or the magnitude of this vector, I will say that it is now creating a new right angle triangle, and the sides of this new right angle triangle are our original vector and 3k cap. Using these sides, I will say that the magnitude will now be the under root of the square of the original vector plus 3 square. If I want to find out this particular length, I will put in the value of our original length and I will say that this length now becomes under root of 5 square plus 2 square plus 3 square. This tells us that if I have to find out the length of any three-dimensional vector, I will find out the under root of the sum of the squares of all their individual components in the x, y and z direction respectively.